Have you ever tried walking in a straight line without any visual cues to guide you? It's harder than you might think. Humans have a surprisingly difficult time walking in a straight line without visual reference, points such as distant landmarks or the horizon. Why is this? It turns out that our brains rely on various senses when we walk, primarily vision, balance from the inner ear, the vestibular system, and proprioception, which is the sense of our body's position in space. Among these, vision is the most dominant for navigation. When we walk with our eyes open, we constantly adjust our direction based on what we see, allowing us to maintain a relatively straight path. But without visual input, like when blindfolded or walking in a dense fog, our other senses take over. But here's where it gets interesting. Our bodies are not perfectly symmetrical. Most of us have slight differences in leg length, muscle strength, and dominant sides. These small differences cause us to push off slightly harder with one foot or favor one side. Over time, this leads to a gradual, unconscious veering to one side, creating a curved path rather than a straight line. Another factor is the brain's internal navigation system. Our brains maintain an internal sense of direction using cues from the inner ear and proprioception. However, this system is not entirely accurate. Over longer distances or extended periods, without visual feedback to correct these small errors, they accumulate, causing a deviation from a straight path. Studies have shown that this phenomenon is even more pronounced in conditions where people lack clear visual references, such as in darkness or dense fog. Research has demonstrated that when blindfolded, people tend to walk in circles, often without realizing it. This tendency suggests that our brains, without visual cues, cannot accurately gauge our direction or correct course deviations, even when we feel like we are walking straight. In conclusion, humans struggle to walk in a straight line without visual reference points due to a combination of brain processing, limitations, body asymmetry, and the inherent inaccuracies in our internal navigation system. Our reliance on visual cues to constantly correct our path highlights how our brains integrate multiple senses to help us navigate the world accurately. So next time you try walking with your eyes closed, remember that your body and brain are doing their best, but without something to look at, the odds are you'll end up off course. So make sure to keep those visual landmarks in sight.